Okay. Hi, Iman. Okay, so hi guys. So today I'm just here to answer your questions, whatever they might be. If you could just ask, that would be easier for me to start off with. Yeah. So, yeah. What can we do? What would you like to do? That's what the question is. Yep. Let's begin. Mm-hmm. Okay. Yeah. Uh-huh. This is it. Okay, so we got Iman and somebody else here. Guys, you guys have to have questions, right? What do you guys want me to discuss right now? It is all up to you. Yeah? Hmm? May I explain mass spectrometry? Well, Andrea, my explanation of mass spectrometry would be the same as you would seen in the video. Mass spectrometry as an apparatus basically works. For those of you on YouTube, I've put the link in for in the description for Zoom. You can ask your questions there. So if anybody wants to ask questions, connect with Zoom there. Okay. Okay. So yeah, somebody asked for. I don't have generic tips. There's nothing called tips. I don't know. I mean, it could be a whole rant of the whole syllabus, but I really don't have any specific tips. What for mass spectrometry, what really works, by the way, is the fact that mass spectrum it's a tool that tells us many things. It tells us fragments, it tells us the number of carbon atoms, it can also tell us the type of halogen bonded to it. So two of the three things are very easy. So for example, uh, one thing is, well, and this is something that you should remember, is that the m and the m plus 1 ratio helps us to find the number of carbon atoms by just simply using this formula where the ratio of the relative abundances is 100 is to 1.1 n, and nobody's asking you how this is derived. It's just that this is the ratio, and if they give you the abundance ratio between the m and the m plus 1 peak, what you must know at this time is, what is the m peak? Okay, the m peak is what we call molecular ion, and this is also known as the mr, and this fellow is your, this has a carbon 13 isotope. Yeah, that's how this works. Okay. Now, what simply, I don't know what all, I can't explain the whole. Guys, this is supposed to be like small things. I have this problem as this. Mass spectrometry is like a whole 2 video lesson that I've already made. I can't propose to do all of it in right here. I can just give you overall summary that this, whatever the ratio of 100 is to 1.1. Let's say somebody said, hey Bilal, it's 31 is to 1.1, 1.07. Somebody tells you that the m to m plus 1 ratio is 31% is to 1.07%. Can you use that to find the number of carbon atoms? All you'll do it is, you need to know that the m and the m plus 1 ratio is supposed to be 100 is to 1.1, and all you do is just solve for n. So 100 into 1.07, this is how you solve for ratios, if you guys remember this from your high school math. And you solve for n, you solve for the closest whole number multiple, which I have a feeling would come out to be 3. So what that tells me is that the number of carbon atoms in the molecule is 3. So that we can actually, using math and mass spec, exactly find the number of carbon atoms. That's where mass spectrometry comes in handy. Yeah. Okay. Now that's one use for it. Okay. The other use is if the molecule has an m+2 ratio also. And the reason why you have an m+2 ratio is that your molecule might have chlorine, and there's one chlorine 35 and there is one chlorine 37, or your molecule has one bromine and bromine is 79, or they're isotopes. So what you start realizing is that mass spectrometer will have a different mass based on the different isotopes we have. So if your ratio, because we know the ratio of chlorine 35 to 37 is 3:1, and we know the ratio of bromine 79 to bromine 81 is 1:1. So if, for example, is a molecule A where the ratio is 56% is to 53%, this is approximately 1:1, which says that therefore A has one bromine atom. And if somebody says, hey, I got M and M+2 in this molecule, but my ratio is 60% is to 19%, which if I do the rough math is about 3:1 or 75-35. Therefore, let's call this molecule Bravo. So therefore you say the molecule Bravo has one chlorine atom. That's what we have. Now, is that okay? Is there anything specific in organic chemistry you can ask? Somebody said in Prabesh. What particular questions? Somebody's asking me a private question. Noman, this can be for anybody. It's just me practicing AS chemistry. So if your session is in November, I can help you solve some of the questions. This is all just helping you with questions, really. You know? So that's what I'm here for. Let me know. Let me know. What else? What else? Come on, come on. Guys, I'm waiting for you guys to ask me something. Okay, while somebody is asking for tips, Iman, one tip is do organic chemistry. In fact, I would say do the end questions first. Organic chemistry is important to study, as a lot of it comes. At least 2 out of the 4 questions will be organic chemistry. So make sure you keep an eye on that. All right? Then This is a very guys. I was expecting people to have specific questions to ask. Hmm. Um. People have specific questions to ask. That's what I would be waiting for. Can you please put them in the. When should it be done? If you're appearing in May, June, Noman, end of March is good enough. End of March. First week April. End of March is great. Yes. Is this does anybody have any specific questions, please? I just feel I'm just sitting here. At least I did some questions last time. Maybe that would have been easier to do, just some questions. Hmm. Hmm. Mm-hmm. Mm-hmm. Yeah. Uh, Anybody? Any specific question? Can you explain when ALC and AL2CL? Somebody said, can you explain when ALCL, AL2CL6 exist? Well, honest to God, somebody asked a good question to ask because people get confused. You see, it's always AL2CL6. It's always this. Unless two reasons. Unless heated. So when you heat Al2Cl6, you can break bonds to make 2 moles of AlCl3. You break them down. The other is you dissolve in water. So it's always going to be Al2Cl6 unless you heat it, the bonds break, or unless you dissolve in water. And then what happens is it becomes actually Al3 plus aqueous ion separately and Cl minus aqueous ion separately. And there are 2 AlCl minus ions and 6 chloride ions. That's what it is. Okay, next up. More questions? So how many hydrogen bombs does a water form? The book says board. Okay, so the funny thing is, you see, it's a trick question because the lone pairs on the oxygen, they make 2 separate bonds. And the H's can also make 2 separate bonds. H's can bond with other O's, and the O's can bond with other H's, like that. So the lone pairs make 2 bonds and the other H's also make 2 bonds. So if it's H2O with H2O, then each is making 4 bonds. But when you take out a billion molecules and you average it out, because you see they have to bond to each other. So basically here, if you think about it, the orange one is making 4 bonds with the red ones, but the red ones are also making 3 more bonds here, you know, here. And if you start finding out the average, on an average each molecule has 2 bonds, but because they bond with each other, if 2 bond with each other, they kind of become 4 bonds. So really each molecule can make 4 bonds. 4. Okay, so does that answer your question, Zoom user? And can you please ask your questions in the everyone chat and not private chat, please, so that others know the question asked and I'm not answering randomly, you know, that way. What else? Anybody? What else? Next question. Amen. Anybody have a question for me? Sure, you can ask it here. Others have a question? Hello, hi. Yes, well, Andrea, you should have understood the shapes, but it becomes it faster to just learn it also. You have to understand how we got them, because you'll have to explain that in paper 2. They will ask you, so why is the bond angles of ammonia lesser than that of water? So you need the understanding, because that's paper 2. If you are asked about bond angles, at times they ask you to explain it also. So knowing it helps. I mean by heart, but also you have to explain it also. Both things have to happen. Okay, so basically, yes, you need to understand that all of AS is, because it's not an A2 paper. Abu Turab, remember, an A2 paper is not an A2 paper, it's called an A-level paper. And what is A-levels? It is the A2 component of the syllabus and the AS component. So second year exams contain all of AS level stuff, which is why the world has now really gone to composite A-levels. Most of the world in the UK does composite, for sure. Yep. Next question. Hi guys, yes. What are the topics that make up most of paper 2? Aman, is organic chemistry that makes up most of paper 2. So if you're learning something organic chemistry, then focus on inorganic. Yeah, learn all the reactions for organic chemistry now, and at least have solved, 10 to 12 papers. That would help, you know. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. What else? Iman's left also. It's not a very popular class today. Mm-hmm, mm-hmm. Are you guys just here because you were afraid of missing out on something, but you didn't have any specific questions to ask? Is that why you guys are here? Just wondering. So, okay, so June 2008, you've really gone to the history of questions, right? Well, you don't need to know the values of electronegativity. Basically, you need to know the trend of electronegativity. So if it's, I don't even have the question with me, but maybe me explaining this might help you. So let me explain this. No, that's great to have done that. That's fine. I'm not judging why you did it. I also use old questions. So across a period, electro negativity, what happens to that? It increases. And up a group, it also increases. So if I know that, okay. So across a period and up a group, it increases. And so what do I know about aluminum? Well, aluminum, calcium is in right here, is in group 2, right? Come on, sorry. So calcium is in group 2 and aluminum is in group 3 and above it. So above and across, therefore aluminum is more electronegative. And you know why you also should know that? Because that's why aluminum makes covalent compounds, because it is electronegative. So does you knowing now that aluminum is more electronegative than calcium, will that answer that question in the worksheet? The great. I am very, very glad then. I am very, very glad. Yes. Then what else would you like to know? Yes, please. Please. Okay. Let's go. Change the name. That's your right name. Is Van der Waals forces a general term? Yes. So Van der Waals forces are basically a general term for induced dipole and permanent dipole. My suggestion is now the last couple of years the examiners are more referring to as ID and PD. Both of these are collectively Van der Waals. And outside it is hydrogen bonding. Right. No, Van der Waals does not include hydrogen bonding. Nope. Nope, 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 nope. Hmm? What else next? Anybody else have a question? Or do you guys want to go back and do your own thing and I'm just sitting here looking like I can, do something else with my life? You know? If you have no questions. You may, absolutely, Abu. You may leave. Absolutely. Good luck, by the way, for your exams. Okay? Andrea, Amen, do you have any questions specifically for me? Can you briefly describe how to make? Well, you need to tell me a particular. Hmm. Basically, the trick for, like, if you want to make a redox an equation from two half equations, that's a whole different thing. If you want to make a precipitation half equation, then the idea is that whatever aqueous ions that make up the solid are part of the ion equation. So the trick is, any species that changes its physical state, like aqueous to solid, or uh, uh, you know liquid to aqueous, gas, like HCl gas plus water becomes HCl aqueous. It could happen there. You could also have H plus ion and OH minus ion becoming water. The point is that these were called ionic equations because they have their ions are changing their physical state, like aqueous to liquid, aqueous to solid. And in precipitation, it's always about it'll always be a cation that is aqueous and an anion that is aqueous forming a precipitate. And generally you might have two solutions, like NaCl aqueous plus, let's say, silver nitrate aqueous makes NaCl NaNO3 plus AgCl. Now what's the ionic equation here? Well, you know that AgCl is a solid. If you do not know that, you can't even make the ionic equation. So you would have to know that first, right? So once you know that is a precipitate, you would say, well, Cl minus aqueous plus Ag plus aqueous becomes Mm-hmm. That. Why? Because these guys, why don't they exist? Because these telos, the sodium nitrate, are both aqueous ions on the right and aqueous on the left. If aqueous ions remain aqueous ions, then it is they're not part of the ion equation. They are what we call spectator ions. Yes. Okay. Mm-hmm. At the last day or two, life in colors, you can please do topical or yearly, it doesn't really matter. At the end of it, topicals are done to figure out if there are certain chapters you are difficulty in. Otherwise, just do yearlies to practice. Just you are, just do yearlies just to practice. Okay. So either or works. If you have problems in specific topics, do those topicals. If you're good with all topics, then do yearlies. Okay. All right, guys. I think I'm gonna head out. Okay. Mm-hmm. All right. So good luck for your papers. I mean, there are a couple of days left. Just keep practicing, and I guess I'll catch you guys the next time. All right. Mm-hmm. Bye bye. And for paper 5, how many yearlies? Paper 5, at least do 10 to 15, 10 papers at least. Mm-hmm. 10 papers. Yeah. Bye bye.